Researchers have developed technology to simulate the movements of soft limbed robots for the first time. Soft robots are primarily composed of soft materials that can allow for mechanically robust maneuvers that are not typically possible with conventional rigid robotic systems. However, owing to the current limitations in simulation, design and control of soft robots often involve a painstaking trial. Motion picture animation and video games are impressively lifelike nowadays, capturing a wisp of hair falling across a heroine's eyes or a canvas sail snapping crisply in the wind. Collaborators from the University of California, Los Angeles UCLA, and Carnegie Mellon University have adopted this sophisticated computer graphics technology to simulate the movements of soft limbed robots for the first time. The findings were published in the journal Nature Communications in a paper titled Dynamic Simulation of Articulated Soft Robots. The researchers have achieved faster than real-time simulation of soft robots, and this is a major step towards such robots that are autonomous and can plan out their actions on their own. Soft robots are made of flexible material which makes them intrinsically resilient against damage and potentially much safer in interaction with humans. Prior to this study, predicting the motion of these robots has been challenging because they change shape during operation. Movies often use an algorithm named discrete elastic rods (DER) to animate free-flowing objects. DER can predict hundreds of movements in less than a second. The researchers wanted to create a physics engine using DER that could simulate the movements of bio-inspired robots and robots in challenging environments such as the surface of Mars or underwater. Another algorithm-based technology, finite elemental method (FEM), can simulate the movements of solid and rigid robots, but it is not well suited to tackle the intricacies of soft natural movements. It also requires significant time and computational power. Until now, robotics have used a painstaking trial and error process for investigating the dynamics of soft material systems, design and control of soft robots. Robots made out of hard and inflexible materials are relatively easy to model using existing computer simulation tools. Until now, there haven't been good software tools to simulate robots that are soft and squeezy. This research work is one of the first to demonstrate how soft robots can be successfully simulated using the same computer graphics software that has been used to model hair and fabrics in blockbuster films and animated movies. The new simulation tool can significantly reduce the time it takes to bring a soft robot from drawing board to application. While robots are still very far from matching the efficiency and capabilities of natural systems, computer simulations can help to reduce this gap.